Okay, hello. It's exactly 10, so I guess we can slowly start. So for some reason the resolution is even smaller than usual, so my beautiful ASCII art doesn't fit on the screen exactly. But what it says is the title of the talk, of course, and it's the no framework dependency injection using Scala and MacWire. And I'm going to talk a bit about MacWire, but also how to create object graphs in Scala using only Scala constructs, how to create modules using traits, how to implement things like interceptors and scopes using Scala only without any frameworks as well. Okay, so let's start. It's going to be only live coding, so maybe something will work, we'll see. Yeah, an important thing, I didn't introduce myself. My name is Adam Warski. So dependency injection. I guess everybody knows, more or less, what dependency injection is. And if you come from Java, the chances are you have used something like a dependency injection framework, like Spring or Juice. But if you look closely at this concept of dependency injection, you will see that you don't really need anything special to do DI. In the end, it is just using parameters, preferably constructor parameters. There are also other forms of DI, like setter injection and field injection, but we are going to skip that. So if we look at the constructor injection, it's just really using constructor parameters, and it's hard to say that using constructor parameters is something very innovative, or that it's something that requires frameworks, right? So what frameworks give us is that we don't really have to write the new keyword anywhere. So maybe that's good, maybe it's not good, but that's like the basic functionality of dependency injection frameworks. So we are going to see how can we do DI with Scala and some other familiar concepts that you may know from Juice. If you don't know, if you're not coming from the Java world, and I must say that a surprising number of people here that I met don't come from the Java world, and I guess that's good. It's going to be like just how to structure programs and create the object graphs in a nice way. The mandatory about me slide. So I'm trying to make presentations without slides, and that's as far as I get. So I have these couple of kind of slides in the beginning. So like daily I'm coding at Software. I'm coding mainly using Scala. So I do use the stuff I'm talking about in practice. Software is a software house from Warsaw in Poland. It's a very nice company. We have a flat structure with 25 CEOs, which is an interesting topic, but for another presentation, I guess. I'm involved in some open source projects like Anverse, MacWire, ElasticMQ. I'm also writing a blog, and I invite you to visit it. I write about various things really related to IT, of course. Not only Scala, but also beacons and Docker, which is very popular lately, so I had to write about it. And I have a Twitter account. Okay, so let's start. We'll start with a blank Scala class, Scala days. Okay, so we are going to make this an object so that we can actually run it. So we will need, as we are going to talk about wiring object graph, so we will need some example classes, which we can then wire and inject and so on, right? So I was trying to think of a good theme, and food is always a good theme, right? Everybody likes to eat in some form. So we are going to build an object graph for a restaurant, and in the restaurant we will be able to order steaks with potatoes. So what do we need to get steaks and potatoes? So the first thing that we need a field where we grow the potatoes. We need a digger, which digs out the potatoes out of the field. And we need a potato farm. And it has two dependencies, on the field and on the digger, right? and the potato farm produces potatoes. And now to get steaks, we need cows. So we have cow pasture, which is where the cows eat grass. And we have the meatery, where the cows, well, you know what happens. And finally, we have the restaurant, which depends on the potato farm and the meatery. Right. And here we will have a single method, order steak with potatoes. Yeah, potatoes is a very hard word to spell correctly. Print line. And so that we can inspect the object graph, we will just print the whole class. Welcome to the restaurant. Here's your order. Okay, so we have an object graph. Like, of course, in a production application, we would have this spread across a number of files and a number of packages, right? But just for demo purposes, I'm going to just put it all in one file, right? So, you know, normally you would have it like in separate files and packages. So we would have like a package for the potato stuff and package for the cow stuff and so on. Okay, so now that we have the objects, like our goal is to invoke the order steak with potatoes method, right? So what we need to do is we need to somehow get a restaurant instance, right? So yeah, using a dependency injection container, we would like add a bunch of add inject, right? We would write add inject here and so on. We would then package it into a jar. We would put it on an application server or just pass it to Juice, bundle up it in a jar. Then the container at runtime would unpack the jar. It would scan all of our classes, see if they have any add inject annotations reflectively. It would inspect what kind of fields there are that needs to be provided as the dependencies. It would then do the wiring and in the end give us the instance. So that's a lot of work for such a simple task. So there are simpler approaches. Like the simplest approach that we could use here is just create the objects, right? So we have the application and we want to run it. So somewhere at the end of the world we have to create the instances, and that's the place to do it. So we can just write field is a new field. We create also a digger instance. We create a new potato farm. It's a very hard word to spell. I don't know why. And here we pass in the dependencies. And yeah, we create the cows. We create the meatery and the restaurant. And it needs... Okay. And now we can invoke our method, right? And we'll run it just so that we can get a nice inspection of the object graph, also only for the demo purposes. I'm going to make these case classes, right? So that we get nice to string implementations out of the box. But that's like not a requirement in any way, it's just to have nice to string. And let's try running that. Hopefully it's simple enough that it will work. And you know, what I'm doing here is like the simplest form of dependency injection. It's manual dependency injection. And it works in a surprisingly large number of situations, even in like mid-sized applications. If you have, you know, we have the objects defined somewhere, and at the end you have the place where you actually run the application. So you can just create new instances like this, you know, pass in the dependencies and so on without any frameworks, and it usually works fine. So an additional thing that we gain here, in addition to using a container, is that we get type safety, right? Everything that the compiler checks that all the dependencies are met, right? So using Juice, for example, the fact that there is a field for the potato farm would be checked at runtime. Here we get it checked at compile time, right? We get we are sure that the object graph can be constructed safely. Okay, so yeah, we have our program running, right, and we can see the whole object graph over here as we expected. Okay, so that's the first step. So far, so good. Now, a couple of remarks when we are doing the manual dependency injection. The first thing is that the vals are evaluated eagerly and from top to bottom, right? So now if we, for example, try changing the order of declaration here, and you can see that IDEA already sees that there's something wrong, the digger will be null because the potato farm is instantiated before, right? You can see it over here. And there's a very simple way to fix it. We can just use lazy vals, right? If we use lazy vals, they will be evaluated only when needed, and actually the runtime will provide the right evaluation order and the right instantiation order for us. Okay? So it's like a good rule. If you are doing manual dependency injection, just use lazy vals. Okay. Another thing that we can simplify, and that's like the first time when we meet MacWire, is that it's a bit tedious to actually write these new invocations, right? So for each class, you have to write the new and enumerate all the dependencies again. You kind of already did enumerate the dependencies over here, right? So what we can do is we can, of course, simplify it with MacWire. That's like the main goal of the project. So we can mix and iterate here just to get access to the wire method. And now instead of using new, we can simply write wire the farm. We can say that we want what to wire, no, the farm, the field. Wire the potato farm. We want to wire the digger. And now we don't have to enumerate any of the dependencies. So I'll explain in a bit how it works exactly. Now here I already deleted. Okay. And now let's just see that it still works. Hopefully it does. Yeah, we still get the same object graph as before. Okay. And in fact, if you look at the generated bytecode, by the initial version and by this version is going to be identical. That's because wire is a macro, and so it runs at compile time. And what it does, it generates the new invocation for us. Okay, so in the generated bytecode, it will be exactly the same as before. So if you would decompile it, you would see here that that's in fact a new potato farm with the field and digger passed in as dependencies. Okay? So how wire works is that it looks at the class at compile time, so there's no runtime reflection, it's only a compile time reflection, and so it's still type safe, and it's checked by the compiler that all dependencies are met and so on. So what it does is looks at the class, looks at the constructor, and for each constructor parameter tries to find a unique value of the given type in the surrounding environment. Okay, so here the surrounding environment is our Scala days object, right? But it can also be a trait. It also looks in super classes and traits that are extended and so on, right? So yeah, if we go to the definition, we can see that it is indeed a macro. Okay, this helps us in two ways. One way is that we don't have to enumerate the dependencies, and also we don't have to actually change the invocation once an object gains a dependency, right? So, for example, let's say that we have very unusual cows which like to eat potatoes, and now our cow pasture depends on a potato farm, right? So we add a dependency here, and we don't change anything else. We run the code, and it will get rewired automatically by the macro, right? So we only need to change it in one place. Yeah, we have it here. Oh, sorry. Yeah, so now the cow pasture depends on the potato farm. Okay, So it also helps us when we add dependencies. Okay, another thing is scopes, right? So when we use vals or lazy vals, everything is essentially a singleton in the scope of our definition, right? So here in the scope of the Scala days application, right, the field is a singleton. There's only one value of the field, right? Because it's a val, it's a constant, one value. And you know, the singleton scope is very common in dependency injection containers, but there are also other scopes. Another type of scope that's often useful is when we want a new instance of a dependency each time it's used. It's called the dependent scope. And we can have it for free when using Scala. So let's say that we want to create a new potato farm each time it's used, right? So just to see how many times it's constructed, I will add a print line here, new potato farm. We are very happy about it, right? So if we run the code now, there's going to be only one potato farm created, right? So now if we want to create a new potato farm each time it's used, that's very simple. We simply change the val into a def, right? It's a method. It's going to be, the new instance is going to be created every time it's used, right? You can see here that we have two. So we have now implementations for the singleton and for the dependent scopes, just using Scala. Okay, so going into modules now. So and that's like the basis of the whole dependency injection with Scala thing, right? And I hope you can see that it's really simple. And I've used it in a number of projects, and I really didn't miss any of the features of the containers. And I guess actually the simplicity is a big plus here, right? You are just using Scala. You are just invoking new. If you need, like, you don't have to use wire, right? If you need to create the object in some special way, you can just write new here. You can use an if. You can just use arbitrary Scala code, right? So the frameworks are often very constraining. Like they are very helpful if you do exactly how the framework is designed. But the moment you want to do something not usual, you have to hack around the framework. So here we just have Scala, so we can do anything we want. That may not be always good, but usually it is, I guess. Yeah. Yeah, it will fail. The automatic wiring will fail, yeah. There will be an error. Okay. Well, if it has a specific type, right? But if they have the same types, no. Then you have to kind of manually say which one do you want to use. So there are no qualifiers. And if you have a good idea how to do it in pure Scala, then I didn't think about it too much yet. So, okay, so now modules. So now that's all good, but if you have a reasonably sized application, right, this part where you actually instantiate all of the objects can get pretty large, right? And we don't like large classes. They are hard to manage. So how can we split that into some manageable pieces? So we can use traits, right? So, a good approach that I found is like, let's say that like these three classes, they form one package, right? It's all the agricultural stuff, all with the stuff with animals goes into another package, and that's a third package, right? Over here. So a good approach that I found works well is to actually have a trait per module, per package, that defines how to wire the objects that are defined in this package, right? So for example, here we can have a trait which will be a crop module. Right, so that's going to be one module. That's going to be the livestock module. And finally, there's going to be the restaurant module. Okay, so now you can imagine that actually these traits live in the packages just next to the classes, right? So what we are doing here is together with the classes and with the objects, and together with the classes that we define, we also define like a default way how to wire these classes and how to use them. Okay, it's not like a mandatory way how these objects have to be used, how these classes have to be used, but it's like a recommended way how to wire them. Okay, and now of course this won't work because we now don't have a restaurant instance in scope. So what we have to do is we have to create like, that's like our cake, let's say. So it resembles the cake pattern a bit. So now the application is going to be the crop module with the livestock module with the restaurant module. Right, and now we can just say app.restaurant. And now we can invoke our method. But this will still won't work, and it won't compile. Right, so if we try to compile it, we get a number of errors here. So for example, the cows, if you remember, eat potatoes, so we need an instance of a potato farm here in our module, and we don't really have one, right? Because it lives in another module, and this module doesn't know anything about the crop module, right? So we have to somehow express dependencies between modules. And there are two ways to do that. The first way is just to use abstract members. So we can say that the livestock module needs to have a potato farm provided when instantiated, right? So now when wiring the cow pasture, the potato farm from here will be simply used, okay? And now this potato farm and this potato farm, they have the same name, right? So they will be like reconciled when we actually create the application from the modules over here, okay? So that's one type of expressing dependencies between modules. It's using abstract members, also quite a basic Scala construct. So there's also a second way, right? The restaurant. Now in the restaurant, we need both the potato farm and the meatery. So we can simply extend the traits here. It's like a much more stiff, much more coupling dependency, right? Because we depend on specific instances of the modules. Crop module with livestock module. Okay, and let's see if it still works. And yes, it does. That's very nice. Okay, and we can see that again we have the object graph over here. Okay, and we have now divided the places where we actually instantiate our objects, right, into some manageable pieces. And again, at the end of the world, when we actually run the application, we have to define which modules we want to use. And again, at compile time, we have the compiler check for us that all the dependencies are met, right? So that there is actually sometimes a concrete potato farm defined, which is expressed with this dependency. Okay, so that's how you can do modules using traits, and that is actually very similar to the cake pattern, except that in the cake pattern you also put the classes inside the traits. So here I'm only using the traits to define like the default wiring of the classes, right? In the cake pattern you also put the classes inside, and that's maybe a reason why you get some additional boilerplate with the cake pattern if you want to have like abstract interfaces and so on. Yeah. Here? Yeah, okay. If I understand exactly, you're asking if I can use self-types here. Yes, I could, but in essence it's the same as extends. So, yeah, you could use your self-types. Okay, so how much time do we have? Okay, we'll see if I manage to do this one. Now let's see interceptors. Okay, so interceptors are very useful in a number of situations. Like the most well-known interceptor is a transactional interceptor, where I want to surround invocations of some methods so that there's a transaction around them, right? But they're also like useful in other cases if I want to do profiling and so on. And they're usually done using AOP and containers just wrap objects in proxies. But in fact, they can be quite easily implemented using pure Scala again. Necessarily, there are some proxies involved, but you don't really need a container to manage all of this. You can do it as a library. Okay, so now let's say that we want to have, we will have the transactional. Where they put it here? We will have the transactional interceptor. So we want all calls to the restaurant to be transactional. Right? So what we do is we simply define that we want to have a transactional interceptor. So it's going to be an abstract interceptor so far, so we don't know what is the concrete implementation. We just declare that we want to have a transactional interceptor. And again, we declare that we want to all calls to the restaurant should be transactional. Okay? So the interceptor is a trait which has an apply method, which takes some type, which takes an instance of a class, right, of some type, and returns an instance of the same type. Okay. So so we have declared that we want to have a transactional interceptor. So now I just have to make some order here with my helping papers. So now we have to somewhere define what the transactional interceptor actually is. And we can do it, like the best place to do it is as late as possible. So when we assemble the application, okay? So here we can say that our transactional interceptor is going to be a proxy interceptor, okay? So the proxy interceptor is an implementation which creates proxies for the instances and returns the proxy. And here we have to provide the behavior of the interceptor. So given a context, and that's the invocation context where we get access to the parameters and so on. So given the context, we are going to print line about to invoke restaurant. Then we proceed with the invocation, right? So that's like the normal invocation context that you maybe know from Java. Restaurant invoked, and we return the result. Okay, and it's not red. That's great. So let's try running that. And yeah, we can see that around the invocation of the order steak with potatoes method, right? Our interceptor is running over here, right? So we have the before and the after statements. So what we did is, in the module, we just declared that we want to have a transactional interceptor. We have used it using the apply method, right, of the interceptor. We can apply it to any instance, right? It doesn't have to be wired using MacWire. It can be any Scala instance, any Java instance. And then we have defined, when we actually assemble the application, that our interceptor is going to be a proxy interceptor with some behavior, right? Because we are in the application here, we can access any kind of dependencies, right? So, for example, we could access a database object here and just say start transaction or something like that, right? Because we have access to all the instances in the application. Okay. So now a note about testing, which is also very important. So let's say that we want to actually test our application. So we will create a new cake, app testing. So see, I can only code with the papers here. We are going to use the same cake as here, so the same stack of modules, but we are going to introduce two changes, okay? So the first thing is that for testing, we don't really want to use any interceptors, so we are just going to say that our transactional interceptor is a no-op interceptor. A no-op interceptor, it's a very simple implementation. In the apply method, it just returns what it gets, right? And so that's a very, I think, easy way to actually replace interceptors for testing, right? I'm not sure if you can do it with containers. And another thing that we could do with that approach is we could actually test that an interceptor was invoked, right? We could provide here some kind of interceptor which records that it was used, right? So, you know, for example, in Java, we annotate a lot. We would use the transactional annotation, but do you actually test that the annotation is there, right? So here you have actually a chance to test that that the interceptor is applied where it should be applied. Okay, so that's like one thing for testing. Another thing is we may want to provide some mock implementations of our dependencies. So, for example, let's say that we want to provide a different instance of the potato farm for testing. So we can do it again using Scala. We just write override lazy val. Potato farm is going to be a new potato farm, right? Some mock object. New potato farm, right? Let's say I will use null here. It's very ugly, but it's, you know, just a demo. Anyway, it's a different instance, right? We could just, if I had a mocking framework, I would just say a mock potato farm or something like that. But I don't. So I will just use the nulls here, just so that you can see the difference. Okay, and now I just do up testing, restaurant, order steak with potatoes, and we can wrap and we can run our code. So yeah, the first you see that we have our old application here, right? And below we have our testing instance of the application, right? And you can see that the potato farm is used in both places because it was used 2 times. It's used once here and it's used once here, right? And also because we have defined now when we override, we have defined it to be a singleton, it's only created once in the testing environment. You know, so with overriding, it's very easy to actually provide mock implementations of specific dependencies, and they are automatically used in all the places in all the classes which depend on them, right? Just using override. So quite a simple mechanism. Okay, there's still some time. So before we go into play, I wanted to show one more thing. But now, again, I need to get to my papers, right? So we can also have some more fun with modules. So here, let's say that we have like 2 implementations of potato farms. Okay. So let's say that we have like we will make our potato farm a trait. And here we have a traditional potato farm, right? But we will also have a new kind of a potato farm, which is a 3D printing potato farm, right? I guess there was maybe not 3D printed, but they made a steak without hurting any cows. So I guess we could do the same with potatoes in the future as well. And it's going to implement, of course, extends the trait, and this one has to extend the potato farm as well. Okay, so we have now 2 implementations of a dependency, right? And we would sometimes like to use the one, and so we would sometimes like to use the other. And there's a couple of approaches that we could do here. So one approach is like in our crop module, when actually wiring the potato farm dependency, we could, you know, look at the configuration. Like we could write if config.traditional, right? Then wire the traditional potato farm, right? Else wire the new one. Okay. So that's one way of doing that, and it's pretty simple. You know, it's just using Scala again, right? looking at the configuration and looking at which object we should actually wire, and it's perfectly valid. But there's also another approach using the modules. So again, we can have, as we have an abstract potato farm and two implementations, we can now have an abstract module which only defines an abstract potato farm, and we can have two implementations. We can have a traditional crop module which extends the crop module, and here we actually wire the traditional potato farm and all of its dependencies. And we can have a modern crop module where the implementations for the potato farm, is the 3D printing potato farm. Right? And so now in this module, we don't really have to wire any of the dependencies for the traditional one, right? We don't need the fields, we don't need the diggers, we just need the 3D printer, which probably should be a dependency, but it's not here. Anyway. Okay, so now we have an abstract module, and we have two implementations of that module, right? And once we have such an abstract module, actually expressing dependencies using the extends of a module, like here, becomes much nicer, right? Because now the restaurant module says it extends, so it depends on the crop module, but doesn't specify which concrete instance, right? It only specifies that it's some crop module, and it contains a potato farm, right? However, of course, when we actually assemble the application, we have to specify the concrete implementation. So let's say that here we use the modern one, and for testing we use the traditional one. And yeah, so like in our main application we use the modern crop module, right? Just by using the right module when we assemble the cake, right? And here we use the traditional module. Okay, and I guess it will fail, yeah, because I'm trying to instantiate. So it will fail in yet another way soon. Right, so why did it fail here in our testing, right? So here we are overriding the potato farm from the traditional crop module. So if we go here, we can see that we are wiring the traditional potato farm. So that field has a type traditional potato farm, not potato farm, right? So we cannot override it with a potato farm, right? So I don't have a good solution yet here. So we have to explicitly type it as a potato farm. So I was thinking maybe of adding like a variant of wire, like a wire exact, which would type the result to whatever it implements, right? So here it implements the abstract field, so it would type it as the abstract field. But if you have any ideas here, let me know. And now it should work. And yes, it did. Okay. Yeah. So like our main application has the 3D variant, and our testing application, yeah, it has the anonymous class that I just wrote down here, right? It's an anonymous class here, and it's an anonymous class down here as well. Okay, so that's like that's what you can do with modules. Okay, and just to the end, I wanted to show you how you can integrate this with the Play application. So I have all the code ready here. It's more or less the same as we saw before, only now it's properly separated into packages. So we have the crop package, where we have our well-known digger, we have the field, which has some additional logic. We have the potato farm, which has the two dependencies, right? It's the traditional variant. We have our crop module, which lives just next to the classes in the same package, right? And here in the crop module, we wire all the dependencies as before, right? We have the cows and so on. We have the restaurant, which is exactly the same. Almost, it doesn't print line, it returns the string. Okay, so that's like our service layer. Now if we look at our Play controllers, so there are some differences here, and I have them written down so that I don't forget about any of them. but of course that single piece of paper has to be missing. What's the last one? Not surprising. So yeah, so we have, for example, the field controller, right? So normally in a play, controllers have to be objects, so they are kind of global, and I don't think it's very nice that they are global. So here we can have like proper classes, which can have dependencies, right? Here our field controller has a dependencies on the field, right? Again, quite simple, right? And yeah, here we have our so yeah, it extends the controller. Here we have our actions, right? So here on the field we have added a harvest method so that we can see some action and interaction using the web app. Similarly, we have the restaurant controller, which depends on the restaurant, right? So it has it's a class with the restaurant parameter, and yeah, we have a play action. So we render the index view with the message that we get from order steak with potatoes. So the first difference is that controllers are classes, not objects, and that they can have dependencies. Now, the second difference is that we need to introduce a global object, and the global object is what play is going to use to actually look up instances of our controllers. So we need to override a class which has a very suggestive name, getControllerInstance, right? And we get the controller class over here. And we need to return the instance of the controller. And there's a facility in MacWire to actually help us do that. So we can first create a map from class to instance, giving any Scala object, right? So here we have the application, which I will show in a second. But the application has like fields like field and so on. So we can create a map at compile time again from the classes to the instances. And then we can wrap it with an instance lookup class, which just uses that map to do instance lookups, which are also superclass aware. So that like when you look up a subclass, if the subclass is not present in the map, it will look at the superclasses. Right. So using these two simple facilities, we can provide play with a way to look up the controllers. Finally, we have the application, which can be any Scala object. Here it is an object, but it doesn't have to be as long as it is accessible from global. So in a global, we also have access to configuration, so we can wire things depending on configuration. And yeah, so here we extend the modules, right? And what we, of course, also have to do is we have to wire the controllers appropriately, right? So when we call wire restaurant controller, it will change it into a new restaurant controller and pass in the restaurant dependency. And the last thing that we need to do is we need to change our roots file. So normally, you would just say get/controllers.restaurantController. Here we have to add the @ symbol so that play actually knows that it has to consult the global object. Okay? And that's it. And hopefully, if I go to Chrome now, so I tried it before, right? We can go over here. You can see that it's actually running. And yeah, we can call harvest, and we can see it's just, we can harvest the field a couple of times, right? And it mutates a variable on the field, which is a very bad thing to do, to have mutable variables in a singleton object, but it's just a demo, right? So yeah, so here we have like a singleton field because it was a lazy val, so it's a singleton in our application. And yeah, we can mutate the harvest count. And if we now go to the main view, you can see that, yeah, the same field is used here, right? And we get our familiar object graph printed out. Okay, so I have a couple of closing slides. Oh, forked. Okay, let me just open them. Right, I don't have much time, so I will skip the comparison with the cake pattern. Although there are some similarities. Like what I call the modules I showed you, I call them a thin cake pattern because I'm only using the part of actually building the cake. I'm not putting the classes inside, and I guess it works pretty well. Yeah, that's a summary of MacWire. there's a couple of more features that MacWire provides. If you're using like a traditional thread-based web framework, you can also quite easily implement request and session scopes in a very similar way as we did interceptors. So just using, by declaring an abstract member in your modules with type scope, and then implementing the scope in the application using servlet filters, for example. You can also do wiring inside methods where the method parameters are used, and you can implement factories where you can find out more on the webpage about that. Okay, again, the resolution is a bit too small. But yeah, the whole project is open source. It's on GitHub, so you can go and take a look. It works with Scala 2.10 and 2.11, and just a small commercial break at the end. So my company, we are creating a code review tool, and we have a very nice motto: "I'm proud of my code." And if you would like a sticker showing that you're proud of your code, just come and talk to me after the presentation. I have quite a lot of them. And yeah, I again invite you to my blog. And if you have any questions, now is a very good time. Yeah. That's a very good question. So the question is, how is it different than passing the dependencies implicitly? It's not. So you can simply annotate all of the dependencies in your classes as implicit, and then declare the objects as implicit. However, I feel that implicits are used in a lot of places, and using implicit that much wouldn't be really readable, and you would have to, change all of the classes to actually say that all their parameter lists are implicit. So you could do that, yes. And I wanted to talk about that, but forgot, and thanks for asking that. Yeah?
How would you go about injecting properties like proxy files?
I would wrap them in some descriptive type, in a simple, wrapper which has a meaningful type which I can then pass around. Okay, I guess that's it. I'm here till the end of the day, and actually until 5 a.m. tomorrow morning, so you can catch me anytime. Thank you.